Hello student, in the last session we have seen the entity architecture and structural design of AFED in architecture. So in this class, in this session you will see how to implement AFED by using simulation tool in VHDL language. So for that I will use software tool that is called as Xilinx. Once you install Xilinx, depending on the version, you will get a icon on your desktop. Here you can see this icon. So when you tap on this icon, it will open Project Navigator. It will open a window, Project Navigator. So once it opens Project Navigator, on the left top corner there is a option File. Click on the option File. You can see sub option. In sub option, click on New Project. So it pops up New Project Wizard where you have to give project name. There is a certain restriction to give the project name. You can give any character except the special character. You can use alphanumeric characters, lowercase and uppercase. Except the special character, other characters you can use. So here I will type HALF AFED ADDER underscore 2. So as I said, you cannot use any special character except underscore. So now here you can set the directory for your project. So depending on the depending on the drive, you can set the directory for your project by navigating the directory structure. Other than that, here there is a option for hardware to select either schematic or hardware description language. I will select the hardware description language, then click on next. Once you click on next, the project wizard gives the device properties. This gives the properties about FPGA which I am going to use in the AFED. So FPGA which I am going to use in the AFED is belongs to Spartan 3 group. So other than that, or Spartan 3 family, other than that, if you click on device button, there is a drop down menu. So in the drop down menu, you select XC3S250E, and similarly package you have to select FT256 or CP132 depending on the manufacturer description. Other than that, I will select the language VHDL in which I am going to write the program. Then click on next. So finally it gives the information about project and FPGA specifications. So click on finish. Once you click on finish, it will pop up new window. Here on the left top corner, you can see the FPGA package is created for my design. Above that, you can see the project name for my design. So now I have to program my FPGA. So for that I will click on my project name. I will right click on my project name. When you right click on my project name, your project name, you will get the option new source. Click on new source. When you click on new source, it will pop up various options of programming our this FPGA package. So this time you select VHDL module, or we are going to program by using VHDL model, and you can give the file name. There is a restriction, as I said earlier. File name can be same as a project name. So let me give half-adder underscore 2 and click on next. So here I will define my entity. So the input for the half-adder is I will take the input for the half-adder A and A and B, and output is sum and carry. Output is sum and carry. So here in direction drop down menu, select output because sum and carry is output, A and B are input port. So click on next and finish. Now the entity is created for the half-adder. You can see here. The entity file is created for the half-adder. Let me click on this. One. You can see there are so many code as pre-written by the software. In that, first one is the library. So here you can see the library used is IEEE.std underscore logic underscore 1164.all, which contains all these libraries contains necessary function to implement the whatever code I have written here. Then entity declaration, you can see here entity declaration, entity and port are the keyword for the software, which is in blue color. Half-adder is the user defined word which is given by me. So entity, half-adder, so here you can see the entity followed by half-adder underscore 2 is port. In the circle bracket, A and B are the input port of type standard logic, of type data type standard logic. Similarly, sum and carry are the output port of type standard logic. That means all these are defined in standard logic library, followed with the end entity with the entity name. Now let's move to the architectural part. So in the architectural part, we need to write the statement for our design. So here you can see pre-written statement for architecture with the architectural name, that is the behavioral of entity half-adder underscore 2 is begin and end with the architecture name. So now we have to write our statement between begin and end. Now the design part of half-adder is written in architectural declaration. You can see here. So as I said, architecture with the architecture name of entity. The entity which we use in this design is half-adder underscore 2 is begin with the sum and assignment statement for sum and carry, that is sum is assigned with the assignment operator. This is the assignment operator A XOR B. Carry is assigned with the assignment operator A and with the B, followed by end statement with the architecture name. Here students, you have to remember all the statements should end with the semicolon, and here all these statements should be written after the statement of begin or after the keyword of a begin. So once we complete the writing of code, then we will synthesize our code. Synthesize is the process of converting the code into hardware. So we normally write the program in a VHDL language here. So VHDL language, once you write the program in VHDL language, you will pass the program into a compiler. Compiler is a tool which understands the VHDL. Compiler is a software which understands the VHDL program. Output of the compiler is fed to synthesis tool. Synthesis tool is a smart tool which analyzes the VHDL code and provide the hardware design for that code. So now here you can see, we'll click on left side bottom corner, we have synthesize XST option is there. We will click on that option. When you click on that option, it will ask for to save the program. So once you get a green tick on the synthesis XST, that means we have written the code complete with the proper syntax and hardware can be designed from the code. Now you can view the schematic of our hardware by clicking on RTL. Here you can see this is the schematic of our hardware, which contains two input A and B, and carry and sum is the output. As I said, you can view the circuit design of our code what we have written in VHDL language by using view RTL schematic. So when you click on view RTL schematic, you will find the circuit design. This is the circuit design of our code. Here you can see the circuit design. We have two input A and B. So the input A and B and sum and carry is the output we have defined in the entity. So in the architecture we have one is exclusive OR gate, other one is AND gate. Output of the AND gate is carry and output of exclusive OR gate is nothing but sum. Suppose if we do mistake in writing code like missing semicolon and we try to synthesize this one. Then this shows error. You can see here red mark. This shows the error that saying that code is not proper. So it says the process synthesis failed, and you can see here this line shows the error, that line 39 unexpected identifier expecting semicolon. So if you click on this, it will take you to that line where semicolon is missing. And suppose if I put semicolon here now, and if I try to synthesis once again by right clicking and click on rerun, then I will get a green tick mark saying that the code is written properly with all semantics and it is ready for hardware design. Now next we will move to the test bench. Test bench is the process of simulating the code what we have written. So for that we will go to our entity. So right click on the entity and right click the option new source, and here you have to select test bench waveform, not VHDL module. You have to select this time test bench waveform, and file name can be same or it can be different also, but we'll give the same file name. Half adder followed by underscore TB. TB indicates it is test bench. The file name belongs to test bench. Then click on next. So here you have to do certain settings. Since our half adder is a combination circuit, you have to select the combination circuit. The different options are there, single clock option and multiple clock option, but it is a combination circuit, so select combination circuit. After that you can select here length of the test bench and initial settings. Let it be default one. Click on finish. When you click on finish, you will get this window where you have to give the input to stimulate our code. So input, as we know, the input for the half adder is A and B, which will take a combination 0 0 0 1 1 0 and 1 1. Let's now give 0 0 0 1 1 0 1 1. So let me take from year to year, that is 100 to 200 0 0, then 200 to 300 0 1. Let 0 0 0 0 0 1 1 0 1 1 0 0. So A and B are the input which will take value 0 0 0 1 1 0 and 1 1. We need not to give sum and carry. Sum and carry should be processed by the software. Once we complete giving input to stimulate simulation, then let's save the project. Once you save the project, you will see here whatever input you have given under this package. Select that particular file TBW with TBW. Select the option here behavioral simulation. Then go to process. Click on simulator, simulate behavioral model, click on and run. Now here you will see three windows. One is the code what we have written, second one is the input what we have given to stimulate our simulation, third one is the simulation output. So other than that, here you can see the simulated output. So here you can see, let me minimize this window for time being. Here you can see between 100 to 200 time length, our input A and B is 0 0, output sum is 0 and carry is also 0. Between 200 to 300 you have given 0 1 combination, A is 0, B is 1, output is sum is 1 and carry is 0. Between 300 to 400 time length 0 0 1 0, that is 0 0, A is 0, B is 0, A is 0, B is 1, A is 1, B is 0, A is 1, B is 1, that is when A is 1, B is 0, we will get like sum is 1 and carry is 0, and when both are 1, sum is 0 and carry is 1, this is the simulated output what we get for our package design. So in this way we can implement half adder by using Xilinx software. Thank you.